Hello again, everyone. Mr. Cruze here with another review for you. This is time with the Chapter 7 Day 2 review. Please remember that your Chapter 7 test is tomorrow, April 16th, 2013. Looking really forward to it. You guys have been doing really well in class, so I hope that this continues. Anyway, continuing on with this review, please remember you also have access to other reviews very similar to these. In fact, the only new stuff that was not on those videos was the natural log, which really behaves like a normal log, so it's not really a big deal. So you can use those as well. I will link those below so you can find them, alright? Anyway, number 1 tells us to graph. Okay, so this is exponential. So let's start just by taking 5 times 1/2 to the x. Let's make a t-table for that, okay? The x values I'm going to use are -2, -1, 0, 1, and 2. Alright. Then I need to plug this in. Well, 1/2 to the -2 is going to be 4 times 5, which is 20. Okay? And you can easily plug these in your calculator if you don't believe me. 1/2 to the -1 is 2 times 5 is 10. And you can kind of see what's happening. We're taking half of this every time. 1/2 to the 0 is 1, times 5 is 5. 1/2 to the 1, or 1/2 to the 0 is 1, right? 1/2 to the 1 is 1/2, times 5 is 2.5. 1/2 squared is 1/4, times 5 will be 1.25. But we have these two things to take care of first, right? So we're going to have to adjust our t-table. The -1, remember when you're dealing with x, you have to talk about the opposite, right? So this actually means add 1 to your x values. And this +2 out here means add 2 to y's. Only the x one is the backwards one, okay? So I'm going to add 1 to all my x's. So -2 becomes -1, -1 becomes 0, 0 becomes 1, and so on down the line. I'm going to add 2 to all my y's. Well, 20 plus 2 is 22. 10 plus 2 is 12, 5 plus 2 is 7, 4.5, and 3.25. There's the t-table we're going to be graphing. Remember, for the most part, I'm going to be looking at your t-tables, but I still want you to graph as best you can. -1, 22 is way up there. 0, 12 is even way up there. 1, 7 is probably the first one we're going to be able to get. 2, 4.5, 3, 3.25. I happen to notice, normally the horizontal asymptote is y equals 0, but we moved everything up 2, which means my horizontal asymptote, which I'm not going to make you draw in, but sometimes it helps, is y equals 2. Please remember to have both arrows, alright? I've seen a lot of you just stop at a single point. The graph doesn't just stop, it continues, okay? It keeps going. Number 2 is almost identical, only a little less work. Let's make a t-table for 3 times 2 to the x. So, same x values. 2 to the -2 will be 1/4, and 3 times 1/4 will be 3/4, or 0.75. Sometimes decimals are easier to graph. 2 to the -1 is 1/2, times 3 is 1.5. 2 to the 0 is 1, times 3 is 3. You notice now we're doubling every time. So 2 to the 1st is 2, times 3 is 6. This will be 12 as well. Okay? Notice this time there is no shifting. There's nothing added on to the x, and there's nothing added on at the end. That's it. Graph that t-table. -2, 0.75 is right there. -1, 1.5 is right there. 0, 3, 1, 6. And there you go. Once again, your horizontal asymptote is just y equals 0, since there was no up or down movement. Okay? In general, your exponential graphs should look like these. Okay? Either going up, exponential growth, or going down, exponential decay. Alright? We didn't really talk about flipping them, but you certainly could. But anyway, they would look like this. Alright? Number 3, the price of a new home is $350,000. The value of the home appreciates, which means increases, 2% each year. All right, so 2% as a decimal becomes 0.02. That's our R value. Write an exponential function. Okay, so the base exponential function is ab to the x. You'll have this on your test. A is your initial amount, so that's $350,000. B is either 1 plus r if it's increasing, or 1 minus r if it's decreasing. Since we're increasing, appreciating, it'll be 1 plus r. So this will be 1 plus 0.02 to the x. So you take 350,000 times 1.02 to the x. And there you go. You've already got half of the problem complete. Write an exponential function? Check. We just did. Now it asks us, how much will the home be worth in 10 years? So we're going to plug in 10 for x. How do I do that? You go to your friend, the calculator, and you type in 350,000 times 1.02 to the 10. I like to use parentheses just to make sure everything works. There you go, and since we're talking about dollars and cents, we should probably go with $426,648.05. So $426,648.05. There you go. That's how much the home will be worth in 10 years. Not too bad there. Okay. Number 5, suppose we invest $2,000 at an annual interest rate of 4.5%, compounded continuously. Very important. Compounded continuous interest is a PERT, right? So, that's a terrible T. A PERT. Well, our principal is $2,000. E is a number on your calculator. R is the interest rate. So 4.5% will translate to 0.045. So it'll be 0.045, and then T will be 3.5. Anyway, this is very simple. Plug it in your calculator. 2,000 times, I like to use parentheses here, E to the 0.045 times 3.5. Close your parentheses. Remember, the 0.045 and the 3.5 are both in the exponent. Anyway, how much will I have after 3.5 years? $2,341.16. All right. It's that simple. All right. Oh, I did them out of order. It's okay. Number 4 here, the amount of carbon-14. I did this one in class, and an object is given by this equation. Not a nice equation, but that's okay. A fossil bone contains half of its original carbon-14. Well, let's pretend that this thing had just 2 whatever units of carbon-14. If half of it is left, how much am I going to have now? Well, I'm going to have 1. Okay, the whole goal of this is what's going to happen when I divide by everything by 2. Well, it's going to be 1/2 equals E to this number. Okay, it's not the nicest problem in the world, I'll give you that, but it's just an equation that you can solve. How do I undo the E? I'm going to log both sides, and in fact, since it's E, I'm going to natural log both sides. So natural log of 1/2 equals the natural log of E to that obnoxious power. But what is the natural log of E? Well, it's 1, so it's going to cancel. So anyway, get natural log of 1/2 equals this. So T is going to equal whatever the natural log of 1/2 is divided by this crazy decimal. So let's figure out what that is. So I go to my calculator, and we're going to take the natural log of 1/2 divided by negative 0.00012. And you get that. And it says approximately, so we're not looking for exact. But anyway, it'll be 5,776 years approximately. All right? Not too bad. Okay. Number 6 says the half-life of carbon-14 is 5,730 years. Write the exponential decay function for a 20 milligram sample. So exponential decay, or half-life, is y equals a times 1/2 to the T over HL power. So our initial amount is 20 milligrams. The 1/2 is there. The T is part of the function, and the half-life is 5,730 years. Boom. Again, half your points right there. Write the exponential decay function. There it is. Check. Now, how much is left after 100 years? We're just going to plug in 100 for T. Very little calculating on your part. For the most part, you're calculating. All right, so 20, and again, I like to use a lot of parentheses here. 20 times 0.5 to the 100 divided by 5,730. Oh, make sure you actually type the 0. And we get this. And look, we start with 20 and we end up with this. Does that make sense? Well, look, 5,730 years is the half-life. 100 years, relatively speaking to that's a pretty small amount. So it would just be 19 point, oh gosh, what was it? 759, but you'll bump that up, so 0.760. This was milligrams, right? Okay. Number 7, convert to logarithmic form. Well, we're going to have 3 to the 5th equals 243. We need to log both sides, but we're going to take the log base 3. And the reason we're going to take the log base 3 is because what happens to the log base 3 of 3? It cancels. And you're just left with 5 equals the log base 3 of 243. And that's it. Alright? If you like, please subscribe to the videos. And of course, there will be a second half of this later on. Please make sure you're studying. I will be in school in the morning if you have any questions. I usually get here at 6. You won't be able to get in until 7, but that's okay. I'll be here if you need me. Just ask, all right? Good luck studying, and I'll see you tomorrow.